Hello. Uh, Today's question is 907 sum of Subarray minimus. Well, it's a medium question. So let's read the question statement. Given an array of integer array, find the sum of min b, where b ranges over every contiguous subarray of arrays since the answer may be large. Return the answer in modulo. So basically what we have to do is out of all the possible subarrays of the array, we have to return the sum of all the minimum values from the subarrays, from all the possible subarrays. Yeah, so that's what we have to return. As you can see here, they have created the list of all the subarrays possible out of this array, and then they have picked out the minimum values of out of all the subarrays. Yeah, so that's what we have done. We can also do this in the same way, but this is not a proper way to do it because the time complexity is going to be out of big O of n cube, because for creating all the subarrays we'll need n square time complexity, and to pick out the minimum values of all these subarrays we will be needing one more loop, so it will make our final time complexity to n, and looking at the constraints that's not a viable option. So we need to think out something, a different way to do it, and here we are going to use a greedy algorithm. So many of you have heard of the problem, the next smallest element, or the next or the previous smallest element. This is also a problem in Leetcode. You can go and search it out. So yeah, we are going to do something similar to that here, to create a subarray that, for example, here how many subarrays are going to have 3 as a minimum value. In this case it's going to be only 1, but for how many subarrays we are going to have 1 as a minimum value. For that, first off have we need to see how many subarrays we can create such that 1 is present in it and 1 is minimum in that. For example, if we choose to do the operation on this array, like 1, 2 and 4, and if we want to keep 1 as a permanent member of our subarray such that 1 is always the minimum value in our subarray, so how many ways we can create? We can go and include elements from the right, and we can also include elements from the left. But the question here is how many steps can we take to the right and how many steps can we take to the left, right? So for in this case, we can take one step to the left and one, two steps to the right because all the elements are greater than 1. And similarly, here I should write it, we can take one step to the left and two steps to the right. And similarly, if we choose to do the same for this element, so how many steps we can take to the left? That's going to be 0. And how many steps that we can go to the right? That's going to be 1. We can't take any step in the left direction because 1 is because 1 is smaller than 2, and if we take one step then we have to include 1, and then the sub array will have a minimum value which is going to be 1, which we don't want. We want 2 to be the minimum value in the sub array. So similarly, we are going to do this same operation for all the elements present in the array, but we are going to do it using greedy algorithm. And for that, we are going to use stack here. So what we are basically going to do is we are going to calculate all the we are going to calculate these values, the values left value and the right values. Yeah, and once we have calculated the left and the right value for all the elements, then we are going to, you know, then our answer is going to be, for example, for one, for one, this element, how many times is this element going to feature in our minimus list, and that is going to be calculated by left plus 1 into right plus 1, and yeah, this is the number of times that uh, 1 is going to feature, and that is going to be 1 plus 1 2 into 3, right, which gives us 6. As you can see here, we have 1 2 3 4 5 6, 6 times 1 has featured in the minimus list. So this same thing we can do for 2. How many times does 2 feature in this list? So left plus 1 into right plus 1, which is going to be for 2, which is for 2 it's going to be 0 plus 1, that's going to be 2, into 1 plus 1, that's going to be 0 plus 1, that's going to be 1, yeah, sorry, and 1 plus 1, that's going to be 2, which will equals to 2. And you can see 2 times 2 has appeared 2 times. So this is what we have to do, and we are going to use stack to do this operation. Okay, so let's jump to the code. So here, yeah, first we will declare a variable n that will contain the length of the array for convenience, and then we will declare a array named left that will be containing all the -1 values, and, we will also need a array name right, which will contain n times, because if it's a default case, because if we don't find any element which is less than that particular element, then the value is going to be n for the right array, and that same value is going to be -1 for all the left arrays. Okay, yeah, and we'll be declaring a variable stack, which will be an empty list. Now we'll be first off we will be constructing our left array, this array. So for that we'll be needing a for loop for I in range n. Okay, and for convenience we'll declare a value that val equals to array I, just for convenience. Okay, now let's assume we have a stack here. Okay, assume we are having a stack. This is our stack, and we are at this position, at this position. Okay, at third position. Okay, we have to start from third position, right? So when we are at third position, and when we need to know that is there any element before 3 that is smaller than 3. So we can see here the stack is empty, so here we will get to know that no, there is no element which is less than 3 before 3. So for that case we'll be, we'll be doing nothing, because we already have -1 at the place of 3. Okay, so we'll be doing nothing there. Okay, so and but if we do have, let's write the code first. While stack, yeah, while stack is not empty and array of I is less than equals to that sorry, array of I is less than or equals to array of the stack minus one value. If there is a value in stack, the index, and if that index value is greater than array of I, then we don't need that index because we can go further beyond that. So that's why what we'll be doing is we'll be popping the stack value until we reach a point where we can't go any further because we have encountered a value that is less than the current value, or we have reached the end of the array. We will be doing this while operation, and after doing that operation, if we still have any element present in the stack, we'll just be, you know, inserting that or changing the value of left of I to the value of that element in that stack, or the index of that element in the stack, right? Yeah, this is this way. And after that, what we need to do is we need to append the current element to the stack such that examine we can examine that we can check that element in the next element. Okay, so stack dot append, we need to append that value. So what is going to be our value? We need I here, right? Yeah, actually I declared this for convenience, but I didn't use it, so it's better to remove it. Yeah, because here we're using array of I. Instead we could have used val there. So yeah, what will this return? What will this do? This will construct our left array, but now we also need to construct our right array, right? So for that we need, first we will do is we can use another stack, or we can just use this variable again by emptying it. Now we have empty stack again, and similar the same thing we have to do once again for I in, but this time our for loop will be running backwards and from top to bottom. For that we'll write n minus 1 comma minus 1 comma minus 1 minus 1 because such so that our loop will run till I gets to the value 0, and it will run in the opposite direction. That's why we're using 2 minus 1 here. Now same thing while, or should I just copy paste this? While stack and array of I is less than array of the value which is at the top of stack, right? But here we are not going to use equals to sign. We're going to only use it once. We don't want to include two times, right? Yeah, after that just have to do the same thing again, this thing. stack dot pop, and if the stack we still have any element present in the stack, then right of I will be equals to of -1, stack of -1, and then again stack, same thing, I. Now we have our left and the right array constructed. Okay, so what we need to do now to have the answer, so let's declare a variable answer here, and for I in range n, okay, and for every answer plus equals to this left I plus 1. As you can see, we have already written the formula here. Left I plus 1 multiplied by right I plus 1, and we also need to multiply the current I value, so that will be array of I, and then we'll be returning the answer. Yeah, so I think we are done here. Let's try to run it. So we encounter something wrong here. Okay, I think we are doing something wrong here. It looks, yeah, I think I know what's wrong here. Think, yeah, here this position, what we need to find is the array of the value of current element should be greater than that of the stack, right? In that case, we need to stop the operation, right? Yeah, now let's try to run it again. Again, we are encountering an error. What that can be. So I'm trying to figure out what's wrong here. Yeah, I think we're doing something wrong in here. Yeah. So here the left is the value of steps we are taking to the left, right? But here we are only, you know, calculating the index. We are using the index instead of using the number of steps. Okay, so to get the number of steps, what do we need? We need to, for the left, we need I minus left. That will be our left value. This is going to be our this value left, and I think we don't need no anymore, because we will be having one extra already. For this one we need minus I. So this is going to be the number of steps minus number of steps to the left into the number of steps to the right plus 1 in both cases. And then now let's try to run it. Okay, So we do have test case passed for this. At least these two are passing. I'll try to submit it. Okay, we have a wrong answer again. So what's wrong? Okay, so yeah, we forgot to do one thing, is that we forgot to put modulo. So we'll do it now, or we can just do it like this: remainder of 10 with power plus 7 into the power 9 plus 7. Now that should work, right? Let's try to run it. Yeah, we have a successful submission. Thank you for watching. Hope you understood. I'll try my best to do it next time. Okay, good luck.